Wasteland Coder here again. Today we're going to talk about test-driven development, or TDD, as it's commonly abbreviated. So the whole idea with test-driven development is you start with a broken test. So you write the test first, that's how it gets its name, and then from the broken test you write just enough code to fix the test, make it pass with code. And then after you have the working code and it's passes its test and everything, then you can refactor to make the code clean, make the test better, whatever it is you need to do, and just repeat the cycle. Write a broken test, fix the test, refactor. That's the whole idea of test-driven development. So, what's the point of this? Why do people do it? So first of all, when you start with the broken test, it does a couple of things for you. First, it validates your assumptions. This could be anything from making sure that you have your parameters correct in your asserts. We've all seen cases where something like the assert equals is called, and then you pass in one object and another object, and they're passed in the wrong order, right? One of these is the expected value, one is the actual value, and different test frameworks have those in different orders, and those are just easy to swap and get messed up. So when you write the broken test, it's easy to verify, hey, what I expected is actually in the expected column, or whatever. The other things that you can validate with that is just, something's actually broken. Especially when dealing with legacy code, you can actually validate a bug actually exists. And then after you fix the bug, you still have the test in place to make sure it doesn't happen again. If that, it's a nice safety net. Another good reason to have a broken test first is that it gives you a goal. It gives you something measurable to work towards. You know you're done when your test goes green. And then all that's left is to just fix, make stuff read better, make it look cleaner, all that good stuff. There are also some design benefits that can come from test-driven development. We're going to talk about those a little bit later after we go through other things. So the next piece to consider is how broken do you want the test? How broken do we want to make it? In past episodes here, we started with a test that actually breaks the compiler. It fails because it can't find a symbol. In this one, right, we wrote a test on a method that didn't actually exist, and then the next pass we added that method and made it go green. So, is a compiler failure the right place to start? It's, everybody has their own preference, and there's probably the, pure test-driven development way to do it that is, yes, you should start with a compiler failure. Write your test without having the actual code, any of the code in place. Some people are going to start with just a, stub method, public string or whatever, right? They're just going to have a stub method in place that just returns null. And in the past episodes, you've seen that that's kind of the first place that we go after the compiler error is you just stub out the method, have it return some default value, and then go from there. That's the way to make sure that the assumption that you wrote in the test is good, that your asserts are in the right order and all that. So it's really just personal preference if you actually want to see a compiler failure or just actually stub out a code and see what it does. Some interesting things happen when you just stub out a method and return some default values. Sometimes that will actually make your test pass if it's such a trivial test that that'll work. sometimes that makes you rethink where you're actually starting your test and writing your code and everything. So that can be interesting at sometimes. The next thing to talk about is probably how much code do you write to make the test go green. This is probably the hardest part for newcomers to test-driven development, as the idea is to write the least amount of code to make the test go green. But does that mean that if your test looks something like, assert actual equals Fred, right? That's the common thing to do for just testing out some legacy code, figure out what it does. If your test actually does that, should you just write your method so that it just returns Fred, right? That's the least amount of code to make that test pass. So if you do that enough, your tests will end up kind of exploding out to a ridiculous number, where you start testing each of the different permutations of what this method could possibly return, right? And that begins to be unwieldy, obviously. And you'll soon find, like, if you actually follow through that approach, that it becomes less code to actually, write out the business case, the logic of how to make this thing pass, build out an algorithm for it, rather than just enumerating every value for whatever specific case. So, again, it's kind of personal preference for, do you just return the thing that the test is expecting, or actually take a whack at the algorithm that it needs to do to get the answer? Right? Do you actually try to implement a Fibonacci algorithm first try to get some green, or do you have it return 1 and then go from there? I like to just take a whack at stubbing out the code and go from there. Typically, sometimes I'll start with the if it's super unclear of what the algorithm should be doing, it can be helpful to start with just kind of enumerating the values, and then to go from there, because that can help flesh out what your algorithm really should be doing and makes it a little bit cleaner in the end. So the next part of the loop is refactoring. Refactor. It would help if that was actually a bit cleaner. That's all that refactoring is about, is making it cleaner. So this can be anything from, reducing a big long switch statement that you made to get a test to go green to some different business logic. It can just be cleaning up the test as well as the code to make it read a bit cleaner and everything like that. Actually split it out into a given when then format, or whatever may make the most sense for this scenario, or anything like that. But we do the refactoring at this point because you already have a safety harness in place with the passing test. So you immediately know if you take a misstep, because your test will fail again. And at this point, you don't want your test to fail again, you want it to stay green. And then after this loop goes, you just start another one, write another failing test, and make it go green again. So I mentioned earlier that there are some benefits of design when you do test-driven development. So what are some of those design benefits? One thing that comes up is that you start with a consumer first type of mindset. And this is because you are writing a consumer first, you're writing the test first, and it's going to consume the code. And so immediately it puts you into a frame of thinking about, what am I going to be passing into this method? What should it be returning? Should it just be, primitives? Should it be an object? Should it be, some wrapper object, some error, an optional, anything like that? Like, just what should it be? So that's useful to get you into that mindset of what's going to be passed in, what's going to come out of it. Another thing is it lets you start simple. Because you're writing the least amount of code, that is usually about the simplest code you can write. It usually is fairly readable, fairly understandable, and it tends to stave off a lot of the complex and difficult algorithms that can creep in if you just go to write the code directly. Right, you may start to write in all the complex scenarios of what might happen given this and that and this, when really the simple approach would have worked just fine. But even if it does need to be complex, it lets it start out simple and then grow to become complex if necessary. And that is typically the biggest reason that this type of development is encouraged, is it lets it start out simple and grow to be more complex when it's necessary. It just lets the code emerge into the final state much more organically than if you come in and try to design it. You're going to get it wrong, you're going to mess some things up. This way helps it grow from the bottom up in a more organic fashion to have less problems with it. And it actually turns out a lot of times that test-driven development is faster than just skipping the tests and coding. And there's you can go and look up all sorts of reasons for that, but really it comes down to those types of benefits, that it starts out simple and grows to be as complex as it needs. Thanks for watching. See you next time.